welcome Senior Vice President and Chief Security Officer, Akamai, Dr. Boaz Gelbord.
Hey, good morning, everyone. It is great to be back here at RSA. I've been coming on and off for around 20 years now, and so good to see old friends and meet new folks. And the thing that's so energizing about RSA is just being in a room full of people, being at an event where everyone just shares the same mission of securing our digital society. And there's years that you come to RSA and you think it's been a little bit of incremental change. Things have been tuned, both in terms of what we can do to protect ourselves and what the attackers are doing. And then there's years where you think there's just a lot going on and so much has changed. This is definitely a year where so much has changed, both from the attacker's perspective and from the defender's perspective. And this year's theme is the art of the possible. And today, with my time on stage, I can do a little brief journey through what does the art of the possible look like over the last year for attackers from their perspective, for us as defenders of our organizations, and what does the art of the possible look going into the future. And we're going to look at that from the application lens. Applications are critical to organizations. The average enterprise has over 1,000 applications. And all of us, when we came over here, whether we traveled from afar or we just came locally, used dozens of applications when we were booking our travel and booking meals and so forth. And those applications, in turn, used many applications to communicate with each other. So securing applications is really critical to securing the modern enterprise. Now, of course, no talk at RSA would be complete without talking about AI. It's the topic du jour. I was thinking, how could I incorporate AI into my presentation? Maybe I could have pulled some of the artwork like the previous speaker, some really cool stuff going on there. Thought I could maybe interview a digital twin. You see a lot of that happening, but I figure one of me is probably enough for you folks. And then I figure I would just go with what I did last year. So last year on this stage, presented the best AI-generated cyber joke as selected by myself. And there's folks who didn't remember any part of my presentation, but months later were telling this joke to me. So if you stick it out to the end, I promise I will give you 2024's best cyber joke, and you can compare. We'll retell the one last year, we'll tell the one this year, and you can see if AI is getting better or not. Now, let's look at a real-life example here in terms of what is happening out in the wild. At Akamai, we carry a pretty significant amount of global web traffic. We see about 11 trillion DNS queries daily. If you think about there's a couple of billion folks on the planet who have internet connectivity. They're, like we said, constantly connecting to applications. They're connecting to each other. That number starts to kind of make sense. And one of the interesting things when we analyze this traffic is that we can see that for many organizations, the amount of traffic going to illegitimate sites can exceed that goes to legitimate sites. So you see an example there of the U.S. Postal Service and an analysis that we did over there. Most of you have probably received these kind of links sending you to a malicious site. It's really staggering when you think about it, because it'd be the digital equivalent of having more fake post offices, people going to more fake post offices out on the street than going to the real ones. But you can also see that our protections have greatly increased, even just in the last year. Our ability to find these malicious sites, our ability to block them, our ability to take action if somebody has actually entered in their information there. So there are both improvements and things that are getting better for attackers. But the one big challenge that we're facing is that the foundations of how we protect our applications are getting shaky. If you would have come to RSA a number of years ago, you'd have seen a whole bunch of vendors on the expo floor touting voice authentication technologies, and how you can authenticate someone using their voice. I'm pretty sure that this year there's no vendor out there that's saying, hey, this is our core product. We're showing you how you can just use voice to protect yourself, because we know that voice can just be made to say anything. You could take a clip of me talking now, and you could run it through a very simple, freely available AI agent and make it say anything that you want. So we know that those foundations are really shaky, and we have to change the way that we protect our organizations. There's the old adage that if you look at somebody's calendar at work, you can tell what their job is. I like to kind of paraphrase that to say that if you look at your security training and awareness program as an organization, you can see what your threat model is. And what we can see is that a lot of organizations still have a threat model that is focused on, do not click on links, do not open attachments, and seeing that as the primary vector. But so much has changed in the application space, and we really need to adjust the way that we look at that. So let's dive into the data a little bit in terms of what's going out there in the wild. Firstly, we're seeing a 48% increase year on year in web attacks. So we can see that attackers are really focusing on web as an avenue into organizations. And out of that, we're seeing that 29% are API attacks, and there's a 109% year-on-year increase in API attacks, so more than doubling. And the reasons for this are several. Firstly, it's hard to inventory APIs. You kind of know what your public-facing websites are, probably have processes internally for setting those up. They're customer-facing or they're user-facing, so it's easier to see what's going on. With APIs, it's hard for an organization to even know what all of its APIs are that are out there. And it's harder to secure them, because oftentimes the logic of an API is much more complex than that of a web application, and it's just harder to know what kind of security model it is supposed to protect and isn't. APIs have credentials that are different. They're keys that are different than the passwords that a web application normally uses. Again, making it harder to rotate those credentials and harder to secure. Another figure that we see here is a 107% increase year on year in layer 7 DDoS. DDoS continues to be a serious problem for web applications. It's the kind of thing that you can't ignore when a web application is fundamentally unavailable to your users. And we'll come back to a couple of examples of that in just a bit. I want to quote something out of the Verizon data breach report that came out a few days ago. Great piece of work, as always, from the folks over at Verizon. And they're reporting a 180% increase in exploit-based attacks, the majority of which have web apps as a vector. So this is just a demonstration that in the wild, we're seeing the exploitation of web apps as being a primary vector for attackers. And then lastly, 20 trillion bot requests in 2023. Bots remain an enormous challenge. There's good bots, there's bad bots, there's gray bots. But if you're protecting your web application, you have to understand how bots are hitting them and how to appropriately defend them. So, we see traffic proliferating, we see applications proliferating, and we see the attacks proliferating. On our platform, we analyze almost a petabyte of data a day, 932 terabytes each day. That's up about 20% from last year. So it's getting more and more complex for us as defenders to spot that malicious traffic, and easier for attackers to do what they need to do. This headline slide is something that almost all of us in this room have some version of. Whether you're a vendor and you're selling security solutions, or you're security team that's trying to make an argument for why to invest internally, you have this sort of problems that are going out in the wild. I'd like to just call out two major trends this year that I think are critical to web apps. Firstly is third parties. We know that just over the last couple of months, there's been third-party breaches, whether it's in identity, in cloud, in VPN, that have been used to get to enterprises' crown jewels. So essentially, this is a form of attackers using what's known as sort of a living off the land type of method, where they're using an organization's own tools and what they have installed and their own resources to attack them. And the uncomfortable reality for us as defenders of organizations is that it's very hard to tell what the risk is that's posed by your third parties. Another big trend that we see, another big thing that happened over the last year is the risk that comes with various components that you install within your organizations. So folks probably saw the XZ-Util vulnerability. This was really a turning point type of issue, where essentially what you had is you had an open source utility that was very broadly used, and had that been taken over by a malicious entity. The maintenance of that had been taken over by a malicious entity, and a backdoor was installed that enabled remote code execution. This is probably the most stunning example of how those type of utilities can pose risk. Luckily, there was an eagle-eyed engineer over, I think, at Microsoft who spotted this and saw some performance differences in how this particular utility was performing, and managed to kind of alert folks before this got out into general distribution. But we don't know how many more of those are out there, lurking in the wild. and it's just really hard to tell how do you identify these within your organization. So let's look from the attacker's perspective. Anything can really be a way into an application. And it's important to understand for us as defenders of organizations that an attacker can easily map out the overall attack surface of a company. And in fact, if you go out on the vendor floor, there's an entire attack surface management sort of industry that's out there that's meant to help you understand how you look from the outside. And once an attacker is on the inside, there's a wealth of information, whether it's internal documentation, in some cases credentials, that make it easier for them to get to what they need to. So things are looking pretty good from an attacker perspective when they're looking to hit your organization. I want to walk through two primary angles, ways that organizations and applications are getting hit that we especially saw in the last year. So let's go back to DDoS. DDoS was at some point considered kind of a solved problem. Like if you had enough pipes and enough capacity, you'd be able to deflect the largest denial of service that might hit your organization. But what we see is that attackers are coming up with more and novel ways to do resource exhaustion on your applications. And they're hitting everything from code to infrastructure. So essentially, in a denial of service, the attacker is trying to get your systems to react in a way that ties up their resources and then makes them unavailable to other legitimate users. A good example of this was the HTTP2 rapid reset attack that came out a number of months ago. And essentially, HTTP2 is a sort of improvement on HTTP1, so it's a better way for web servers to serve information because they're able to handle multiple requests, up to 100 requests, in one TCP connection, rather than in HTTP1 just handling one. The challenge is that this enabled attackers to tie up sort of 100 times the web server rather than just the one. You can think of an analogy where if you wanted to execute a denial of service against a pizza delivery service, right? And if that pizza delivery service takes just one order at a time, you could call them and you could say, hey, here's my order. And then you'd be on the phone and you say, well, actually, I'm kind of changed my mind. This is my order now. And that would tie up the service so that a legitimate caller couldn't order a pizza. With HTTP2, the pizza company is willing to take 100 orders at a time. So you call them and you place an order for 100 pizzas, and then you say, well, actually, I want to change my order, and I only want olives on half of the first one and mushrooms on the second, et cetera. And you've now tied up the service for much longer than you did the first time around. And there's multiple examples of how attackers are looking at the complexity of a modern application in all of the different ways that it responds, whether it's on the web server level, on the DNS level, on things that are specific to its code, and says, how can I exhaust the resources of that so it does more work than it needs to? One thing that's also probably important to call out here is that there has also been a variety of FUD regarding DDoS attacks. I remember a few months back there was an article that talked about a DDoS attack created by toothbrushes. Did anyone see this? It sort of came out, and I got to admit, I fell for this. When I first saw it, I thought, my goodness, this is worse than we thought. And then it took me a couple minutes. I'm like, maybe this isn't quite right. Anyways, turned out that it wasn't right. I don't think we're going to have toothbrush-level attacks anytime soon. But we are seeing a lot of IoT devices which can be garnered up into a bot army and used for denial of service attacks. Sometimes it's because default passwords are being used in those IoT devices, and then other times it's just because attackers manage to kind of garner up ways to exploit those devices in ways they were not intended to. The other thing I want to talk about briefly is exploiting vulnerabilities. So in 2023, there were nearly 29,000 CVEs published, vulnerabilities that were published and that can exploit anything from a piece of code to a firewall to a vendor product or whatnot. Are there any folks in this room whose full-time job is watching vulnerabilities, understanding how they affect your organization? I think there's a few people raising their hands. So if you're sitting next to one of those people, please thank them. They have a very, very difficult job. Really hard to look at all those 29,000 vulnerabilities, understand how they affect you. It's gotten even more difficult because there's been challenges recently with the National Vulnerability Database and how you track all those vulnerabilities. There's a lot of different sources of truth. So this problem is getting harder before it's getting easier. And it's a real challenge to know where these vulnerabilities are lurking. So let's shift gears and talk about what can defenders do in this context. So the good news is that we do have opportunities available to us that weren't there before. And I think one of the biggest is what has been called, in some cases it's called zero trust, and it's been, terms have kind of morphed over time. But the ability to look at your organization and say, how do I make sure that things can only get to what they need to within the organization? And then how do I ensure that I contain the blast radius of a potential breach or potential intrusion when it occurs? I think the key thing for defenders in terms of how to apply this is the notion of being selective about controls. There's so many different solutions that we could implement, but we only have the bandwidth for so many, right? If I were to ask, for example, who here in their personal lives, when they drove over here or took an Uber over here, wore a helmet inside the car? Anyone? Maybe you want to talk to the guy in the back who raised his hand there, but generally nobody does that, right? It would probably help you, right? There are scenarios in which wearing a helmet in a car would probably save your life. But for most of us, we look at it and say, it's not the kind of control that matches. And it's the same thing with applications. A lot that we could do, and you have to watch and be selective to see what you are going to do. So really, in terms of securing applications, the important thing is to look at what you have and ensure that you have a very strong understanding of how your threat model matches the different components of your application from code to infrastructure. This is a highly non-trivial thing to do. It requires an organization to have things like inventories that tie between those different components. And I think one of the most critical parts of what a company can do in order to address this challenge is to start with a risk analysis. Of how their code and their applications and their infrastructure tie together. This is a lot harder to do than it sounds. I also just want to mention for folks who didn't see it, there was a new revision to the NIST framework 2.0 that came out. It's the first one in 10 years. And it added this new govern function to the existing 5 of identify, protect, detect, respond, and recover. And so there's a lot of these kind of tools that enable you as an organization to look and say, this is how I'm going to apply sort of a risk lens to defending applications. So just a really quick recap before we jump into the future. The ability to discover and observe and enforce applications is really critical. If you think when we started out, we were saying you got to make sure that you're applying the right controls. You're not applying sort of yesterday's controls to today's problems. And I think in application security, this is especially critical. This year saw the passing of Daniel Kahneman, who was a Nobel Prize winner, who wrote a lot and whose seminal works were about how our view of risk is skewed. We bring bias to how we view risks. We do it based on previous experiences. This is, I think, a really critical, this notion of how do we get an objective lens to risk to securing applications. And I encourage all of you to read some of his works in that respect. So to recap, when we look forward, to look forward into the future, want to mention a piece around multi-vendor and interoperability. I think one of the biggest challenges that we face in securing our applications is in connecting the different tooling that we have. And so this is really one of the foundations, is to ensure that the different tools you have around the observability and the discovery and the monitoring of your applications that we mentioned earlier are very tightly coupled. The other thing that we're seeing a lot of is developments in the policy and compliance space. So just over the last year, we've had CISA, for example, published a 447-page draft around cyber disclosures. We see things coming out of various regulatory agencies. And these are really focused on the notion of how you disclose vulnerabilities, how you inventory things, how you have risk management in your program. Securing your applications moving forward is going to be really heavily dependent on making sure that you integrate that compliance work with the technical security parts of your program in a seamless and efficient way. And that's much easier said than done, but I think it's going to be increasingly important moving forward. And then lastly, AI. AI is going to fundamentally change a lot of pieces of our overall security model. The most obvious spaces, which we mentioned earlier, are identity and user authorization. This is moving very fast, but also in different places like how we do our security operations and how we do our security monitoring. this brings us full circle. I promised at the beginning that I would give you last year's AI-generated cyber joke and this year's AI-generated cyber joke. So, with apologies to those who heard me on stage last year's joke was, why did the hacker plant the tree deep in the ground? Why did the hacker plant the tree deep in the ground? Because they wanted root access. So assign a mental score to that joke. This year, as I was typing away with ChatGPT and other AI tools, I tried to raise the bar, because that last joke could be at any security conference. I said, give me an RSA-specific joke. So here is the RSA-specific joke of 2024. Why was the CISO confident in the factors that went into the security metrics they presented at RSA? Again, why was the CISO confident in the factors that went into the security metrics they presented at RSA? Because they knew the numbers were prime and there would be no problems. Thank you very much, everyone.